Welcome Geometry to Chapter 4, Section 4, Congruent Triangles. How fun. Go ahead and pause the video. Try these questions. Come on back. All sides and angles of triangle FGH are. What is true about these angles? Congruent, the third angles theorem, right? And what does it mean for two segments to be congruent? Same length, same measurement. All right, today we're going to use properties of congruent triangles and prove triangles congruent by using the definition of congruence. So, geometric figures are congruent if they are the same size and shape. So corresponding blanks and corresponding blanks are in the same position in polygons with an equal number of sides. Corresponding angles and corresponding sides, right? Two polygons are blank if and only if their corresponding sides are congruent. Two polygons are what type of polygons? Congruent polygons, right? Thus, triangles that are the same size and shape are congruent. Really nothing new here, right? Properties of congruent polygons. I love these symbols that we use in math to show congruency, right? We can see that even though triangle ABC is kind of in a different orientation than triangle EDF, we have angle A corresponding with and congruent to angle D, shown by the single arch, right? We have angle B corresponding and congruent to angle E, right? And then with the three arches, we have angles C and F being congruent. Corresponding sides can be labeled with the same hash mark, right? So one mark tells us that AB is congruent to ED or DE, and we can see that side BC would be congruent to the side that has the two marks, right? And so on. So we can say BC is congruent to EF, AC to DF. This can be said of these polygons as well. Notice when they give you the statement PQRS is congruent to polygon WXYZ, even without the figures present, we could say PQ is congruent to WX, right? Or angle P is congruent to angle W, just using the sentence. And sometimes that's the best way to do these sorts of things, especially if you're given the sentence, right? So go ahead and complete this and come back and check. You should have statements matching these. Love these helpful hints. Two vertices that are the endpoints of a side, a single side. We consider them to be called what types of vertices? So it's like two students who are sitting kind of next to each other. We consider them to be consecutive, right? Consecutive. Another way to say kind of right next to each other, right? So P and Q here, these vertices, are consecutive vertices. So to name a polygon, write the vertices in consecutive order. For example, you can name that polygon PQRS as QRSP or SRQP, but not PRQS. Let's go look. Not PRQS, like we hop straight over the entire polygon. We wouldn't name it that way. We need to name it with consecutive vertices. In a congruence statement, the order of the vertices indicates the corresponding parts. As we said, P corresponds with W, Q corresponds with X, R with Y, and S with Z. So as we've said, when you write a statement, such as triangle ABC is congruent to triangle DEF, you are stating which parts are congruent. So which angle is congruent to angle C? Angle F, that's correct. And which segment is congruent to segment FE? CB, very good. So without even looking at the image, given triangle PQR is congruent to triangle STW, identify all pairs of corresponding congruent parts. Pause and come back and check your work. You should have these corresponding parts. All right, and here we have a quadrilateral being congruent to another. So go ahead and pause once again and take a moment to carefully identify the corresponding congruent parts. Don't come back till you're sure you have it. And there you go. I'm sure you're doing great. So, given triangle ABC is congruent to triangle DBC, find the value of x. Okay? So we know that angle BCA and angle BCD are right angles. How do we know that? They form what? A perpendicular pair of lines, segments. See that? So we can say that angle BCA is congruent to angle BCD. We can say that by our right angles theorem. The measure of BCA must then equal the measure of BCD, and that's based on this congruency, isn't it? Definition of congruent angles. So, do we know either of these angles? Yes, we do. We know BCD, don't we? And so we can say that BCD is 90, and we have an expression to represent BCA. We can now set those equal. And we can do this because of our substitution. So now we will isolate x, won't we? So let's see how they did it. They used what? On both sides they used addition, didn't they? Addition, property of equality. And then the division property would give us x equals 53, right? And they say divide both sides by 2. Awesome. So you can check your work by substituting this back in. And 2 times 53 is 106, minus 16 is 90 degrees. Okay, given triangle ABC is congruent to triangle DEF, find the value of x. So what we know here is that these triangles are congruent. So we can say that AB is congruent to DE. Just looking at this congruency statement, we can see that this triangle and this triangle are oriented a little differently on the plane here. But with the statement, we can easily see AB corresponds to DE. And that is corresponding sides of congruent triangles are congruent. So if they are congruent, what can we say about these segments? They are equal. Definition of congruent parts, right? And what do we know about AB? It equals this expression, right? And we know DE equals 6, right? So we are using our substitution. And now we simply solve for x. Add 2 to both sides, addition property of equality, and divide, division property of inequality, or of equality, and we have x equals 4. Let's plug that in and prove this. 2 times 4 is 8, minus 2 is 6. 6 equals 6. Very good. All right, so now we're going to practice a proof here. The statements have been given, and you need to state the reasons. So we know that angle YWX and angle YWZ are right angles. We know that YW, that segment bisects angle XYZ. And W is the midpoint of XZ. XY is congruent to YZ. So we're setting out to prove that XYW is congruent to ZYW. So it's nice to be given these statements, isn't it? We know that these are right angles. How do we know? Given. So we know that YWX, angle YWX, is congruent to angle YWZ. And that is the right angles congruency theorem. We're told they were right angles, so we have the right angles congruency theorem. YW bisects XYZ, here it is, we were given, right? If it bisects XYZ, then XYW and WYZ are congruent. That's due to this bisecting, right? Definition of a bisector. We also know that W is a midpoint of XZ, another given piece of information. And if it is the midpoint, we can say X to the W is congruent to Z to the W, right? And that's based on this midpoint definition, right? Definition of a midpoint. We can say that YW is congruent to YW. How can we say that? YW is congruent to YW. Remember that term? It is reflexive property of congruency. And we can say that angle X is congruent to angle Z. How can we say that? Our third angles theorem, since we know the other two. Whoa, where am I going? All right. So therefore we can say, or we, not therefore, but we can also say XY is congruent to YZ. That was given too, right? So now we can say what we were setting out to prove, that triangle XYW is congruent to ZYW, the definition of congruent triangles. Let's try this again. And AD bisects BE. BE bisects AD. So AB also is congruent to DE. And angle A is congruent to D. So we're setting out to prove the triangle ABC is congruent to triangle DEC. Well, we are given that angle A and angle D are congruent, right? And BCA is congruent to CD. BCA is congruent to DCE. How are these two angles congruent? We know that because they are vertical angles, right? We also know that angle ABC over here is congruent to angle DEC over here because they are the third angles in these triangles, right? Where we already knew the other two angles, so the third angles must be congruent. So we've proven that all three angles are congruent, so now we need to look at segments. AB is given that it is congruent to segment DE. We know that AD bisects BE and BE bisects AD. This was given, wasn't it? And so we can say that BC is congruent to EC and AC is congruent to DC. And that's our definition of bisectors, right? So we have now shown that these triangles have all angles congruent and they have corresponding sides that are congruent. So we can say that they are congruent by our definition of congruent triangles. Okay, here's a diagram of a real world situation, and so we are asked to prove that JKN, that triangle JKN, is congruent to triangle LMN. Okay, so, and we're given this information. So pause and read it, and now let's start. We know that JK is congruent to ML, JK and ML, and that was given, right? We also know that JK is parallel to ML. JK and ML are parallel, also given information. And now let's look at angle JKN. So this angle here is congruent to NML, NML. And this has to do with these parallel lines, right? We would call this angle and this angle alternate interior, right, angles, which are congruent. Okay, let me see if I can spread this out a little bit. JL and MK bisect each other. And we have that as given information, right? JN is congruent, since they bisect, and JN is congruent to LN, and MN is congruent to NK or KN. That's our definition of bisectors. We can say that K and J, that angle, K and J, is congruent to M and L. How are these two angles congruent? That's right, they're vertical. And we can say finally that KJN is congruent to MLN. There are two ways we can say this. We can see that these two are also alternate interior angles, right? Or we can use the third angles theorem because we've already shown the other two pairs of angles in these triangles are congruent. So finally, we can say that triangle JKN is congruent to triangle LMN because we've proven that all sides are, corresponding sides are congruent and angles as well. So definition of congruent triangles. Okay, go ahead and try this. Come back when you're done and check your work. I'll just show you the answers real quick. All right, so number 1, 2, 3, and now you had to create the statements and the reasons. Good job. And here you go. Have fun with your figures today.